See, how cool is that?
Otherwise, college.
I was just looking at.
Reason is it going up?
I don't know. I don't hate it though.
I did not take, I did not.
That's awesome.
Should be fun.
You should find it.
That's the plan.
Yeah.
Yeah. I mean.
Is it a box?
Were you looking the other day? She's like, yeah.
Right.
I was using her passport. She wants, she's like. She has to talk to you. Yes, it's like, there's okay.
Drop it down.
How did you get a box?
I wish it was nice weather, so we could go on like some nice hikes. And train home. So we'll see. I don't know, like. There's a pretty, like home for.
Yeah.
Go to. Franklin's birthday.
Did you find Alex's AirPods or?
Franklin's really fun.
There's a black. It's like a black.
We'll see.
You
You know, it's just nice restaurants, so it's there.
were just like, here's a box, let's put it in there.
Okay, on page 50 of the class pack, simulation is descriptive. Oh, let me check the status of the Zoomers. I don't see what's going on. Here we are. Kevin Daly, you hear me?
Yeah, I got you.
Okay. It's just you and me, I think. There's a few more. So the class pack, page 50, simulation, unlike linear programming, simulation is only descriptive. It describes how good a solution you suggest is. Simulation is a highly detailed form of analysis, and thus,
Can you
Yes.
share your screen?
yes. Thank you. Now we're up to 13, but I'm expecting 35. All right, Sam, you hear me all right?
Yep, and I can see the screen. Thank you.
Okay, thank you. So simulation describes how good our solution is. It's potentially, simulation is potentially too detailed in order to be able to find an optimal solution like linear programming can. Simulation is defined as doing experiments on a model to see how uncertainty impacts you. You can't use the average values of uncertain inputs. If you do, you'll get the wrong answer. Does not give you the average value of the outcome, therefore you get the wrong answer. We have to embed uncertainty directly within the model using typically the RAND worksheet function. We saw last class uniform 0 to 1 equals RAND. Uniform between a small number and a large number. The small number plus the range times the RAND. Normal with mean mu and standard deviation sigma, norm.in of RAND comma mu comma sigma. Empirical VLOOKUP of RAND in a range comma 2 interval form. We're going to look at 4 examples. We're got a good start, but didn't finish the news vendor simulation last class. Then we'll look at these 3 examples this class. Let's go back to the news vendor simulation. Here's an announcement. If you've done well in all of the homework so far in the course, you may exempt the final exam with a grade of PA in the course. That's strictly optional. Email me if you're interested in discussing that option. You may email me without committing to exempting. All right, let's go to newspaper simulation. A sarcastic joke. You studied so hard, you had no time for interviewing. You bought the news vendor stand at 5th and Broadway. Here is a list in, okay, I'm in sheet newspaper simulation. Your sharing is paused. Stop sharing. Zoomers, can you hear me? I mean, yes, first, can you hear me?
Yes. Yep.
Yes.
See my screen?
Cannot see your screen.
We see the class pack.
If you press the green play button, you hover over the yellow bar again, and then resume sharing.
Okay. Do you know what I did to interrupt, to pause sharing?
No.
Okay. Right here might have explained it. Okay, Zoomers, you see the Excel sheet?
No.
No.
I think you're only sharing the one.
Stop share, share screen, this one, share. How now?
That's good.
Yep, we get it.
Okay, thank you. So I'm in book, sim newspaper review. I'm in sheet, newspaper simulation. We have 20 days of demands that were observed. That's a little small. For teaching, I'll live with that, but I'd rather have a few hundred of observations on demands. Here they are, sorted, the same numbers appear in column F, sorted, whereas column B was day 1, 260 papers demanded. Day 2, day 3, sorted. There were 20 days, so we make the assumption that future demand will equal 196 with probability 1/20th. And that corresponds to an interval of 0 to 0.05. The next possible demand, 260, will have probability of 1/20th, and that corresponds to the interval of 0.05 to 0.10. 292, 1/20th. All of them have demand of 1/20th except for 348, which has demands of 3/20ths. 1/20th is 0.05, 3/20ths is 0.15. So look at the length of this interval in the heavy border, 0.40 up to 0.55. The length of that is longer. It's 0.15, 3/20. If a random number lies in the interval 0.40 up through in 0.55, we say simulated demand is 348. 400 demand has probability 2/20 because it appeared twice. 400 has interval 0.1 rather than 0.05. So that's the first thing to set up your VLOOKUP compare values if you're going to use empirical distribution demand. Let me hide some rows. I don't think we need to see these. Blue-gray is data, although that coloring convention is not rigorously enforced like in linear programming. You may or may, no standard color conventions are required in simulation. You buy newspapers at $1.10 each the day before. You sell them for $1.50. How much should you order? Red border, let's try 400. I have 50 simulated days. Days 1 through 50 in column A. The random number in column B. We don't have to put the random number in a separate cell of its own. We could embed the random number directly within the formula. For teaching, it's a little easier to see what's going on, to confirm what's going on, to understand what's going on, if the random number is in its own cell. So let's look at a few of these demands. Let me spot check these green cells. 0.9257, I say simulated customer demand is 440. Let's look in this green interval between 0.90 and 0.95, 440. The next day, the random number is 0.244. That is between 0 and 0.05. 0.244, no, it's not 0.244. It's in this interval right in here. 304. The second demand. The next two demands coincidentally were equal, 0.50, 0.41. That's in the long interval. 0.50 and 0.41 are both in this interval. 348. Okay, spot check, please, column C. Let me talk a little bit longer. The revenue is based on the two numbers, how much do customers want to buy and how much did you choose to stock? You chose to stock 400 in this simulation. Demand is 440. You sell the smaller of the two, 400, at $1.50 and you get $600. Confirm that, please, convince yourself that 600 is $1.50 times 400. And 456 is $1.50 times 304. If you stock 400 and customers want to buy 304, you sell 304. That's harder to do in your head. Half of 300 is 150. Half of 304 is 152 plus 304, 456. The cost is quite simple. 400 multiplied by $1.10. Whatever number you ordered, the profit is the difference. Let me give you 3 minutes to review columns A, B, C, D, E, F, starting in row 48. a rich guy forgot his wife's birthday. She was furious. She said, there better be something for me in our driveway tomorrow morning. That goes from 0 to 200. The next morning, she saw a package in the driveway. It was a scale. One version of the joke goes on to talk about the funeral arrangements. All right, let's go on. We all have the same random numbers. The hidden rows are all the same. The average daily profit in F99 is $73, almost 74 per day. I'm forced to admit that in F100 you could hard code the 312. That is 7 days a week. No, 6 days a week times 52 weeks. Probably would be better if you put the number in a different cell, because he can control whether he works 5 days per week or 6 days a week or 7 days a week. But I can see the argument that if it's given that he works 6 days a week and can't change, then 312 can be hard coded. Annual income, not quite 23 grand. It appears in the summary table. I think you'll appreciate the salaries you are going to command in the near future. So 400, that's how good it is. Simulation describes 400 as being worth not quite $23,000 a year. Let's change it to 300, the order quantity. The red border cell, the order quantity. You can check it if you like. 35,568 is clearly superior, and I believe is the optimal solution. I just optimized by enumeration. Try one value, try another value, try a third value. It turns out in this simple problem, there is a formula for the optimal solution, but it does not generalize. In real problems that have multiple variables, there is no way to get the optimal solution. So there we have our first example. Let me give you another 2 minutes. We charted, you don't have to know charts for this course. Sheet 1, I put the announcement in. A minute and a half, and then we'll go on to the next example. Here's a humorous comment. Most people, even non-technical people, are comfortable with the concept of the mean. They would probably not use that term. They would call it the average, or the expected, probably call it the average. Not everyone, however, is comfortable with the standard deviation, which quantifies the amount of variance in the observed data. Here's a way to make fun of that. Rover, come here. Come here, Rover. You're a good dog, Rover, and I want you to come right now, Rover. We know that's all the word. That's all the dog hears. He hears the tone of voice and 1 or 2 words. So if we tell the boss the expected value in the standard deviation is 200, what does the boss hear? Like the dog, he hears the value is 100. implying that not everyone is comfortable with the concept of a standard deviation, a quantification of the uncertainty. All right, same book. We have some in-class problems to work. Previous sheet, normal probability and in class. I want to illustrate the worksheet function and or. We had a glimpse of the or worksheet function, but I flew right over it, saying we'll cover the details later. It's later now. I want to illustrate the use of the and. The and tests whether multiple tests are all true. And would better be called all. If you have 5 tests and you want to know if they're all true, equals and, open parentheses, first logical test, second logical test, third, fourth, you put all the logical tests in parentheses. For example, the use of the and with 2 tests, B50 is big enough and C50 is big enough. Let's look more carefully. These customers in this small example, Acme, Jones, XYZ, Kent, Smith Brothers, and Brown, have ordered this many units this year and have spent this much money ordering from us this year. We give a discount if the customer has already ordered. We give a discount on future orders if the customer has already ordered this year a sufficiently large number of units and a sufficiently large dollar amount. So you can't buy 100,000 paper clips and expect to get the discount. You can't buy only $1, or you can't buy $299,000 and expect to get the discount. You will not get the discount in the first example unless you have previously ordered 60,000 units at $300,000. We sell expensive items like file servers. We sell inexpensive items like printer cartridges and paper clips and pencils. In the first example, discount if both are required, both a large enough number of units and a large enough dollar order. In D50, I say equals if. I want the long form of the if because I want to control the value if true and the value if false. The value if true is I-59, which is the 10% discount. The value if false is text. NA, not applicable, 0, whatever you want to call it, no discount if the value is false. Equals if. Excel recognizes that as a single logical test. In fact, there are 2 tests there, but the and converts it into a single logical test. Are they all true? In the first example, 73,000 is large enough number of units. You need only 60,000 units to get the discount. $440,000 and a little is large enough. So the logical test is true. And blah, blah, blah is true. And he gets 10%. In the second customer, he does not have enough units. Only 40,000 is not enough. You need 60,000. And he doesn't have enough dollar orders either. You need 300,000. So his discount is not applicable. Third customer, 70K is big enough, but $280,000 is not big enough. They are not all true. So the discount is not applicable. Not applicable. The ones in yellow get the discount if we require both units and dollars to be large. A related concept is the OR worksheet function, which tests if any one of them is true. For Acme in row 50, The units are big enough, the dollars are big enough, so that company passes the OR test. OR is true. Jones, neither one is big enough. 40,000 is too small. 242,000 is too small. So 40K is not bigger than 60. 242K is not bigger than 300. So the second customer does not get the discount. I should look right here. I'm looking in column E. Third customer, XYZ, he has enough units but not enough dollars. He gets the discount. I've changed the example. In the first example, both are required. That's the way I initially described the problem. But now I'm changing it to say a customer gets the discount if the customer has purchased either enough units or enough money, or both, of course. Draft start for the formula, the short form of the if worksheet function equals logical test. Let me give you 2 minutes to review the concept of the either, of the or and the and. Let's look at the and worksheet function in a typical simulation. I want to be in the same sheet with D28 near the top, D27. We sell expensive items like yachts, Porsches, airplanes. The rule is that 14 days is an acceptable delivery date. We want to simulate whether customers will cancel the order or not. And the rule is if we actually deliver or we promise delivery within 14 days of the purchase, nobody cancels. But if the best we can do is to cite a delivery date more than 14 days in the future, half the customers will cancel. Does he cancel? F28, if and. I want to first of all see, will the delivery be more than 14 days? If that is true, it'll be more than 14 days. Then I check further, is a rand bigger than 1/2? If it is bigger than 1/2, then we conclude that he cancels. The simulated customer cancels. 24. All right. I just pressed delete, as you heard, to recalculate. With the random numbers I had, nobody canceled. 224, 38. That's that's about 12 days in the future. Nobody cancels if you promise prompt delivery. Prompt in this context for your $200,000 yacht that you've been saving up your whole adult life is 14 days. If it's less than 14 days, of course he doesn't cancel. If it's more than 14 days, E29, let's see, that's February 21st up to March 13th. There is a 50-50 chance he will cancel. So we check this, and it's more than 14 days, then we check a rand. If the rand is big enough, then we simulate that he cancels. Next example, if it's more than 14 days, it's not. there's really no reason to look further. The only way he will cancel is if both are true. The RAND is big and the delivery is poor. Delivery time is tardy. And the delivery time is not tardy in this case. February, it looks like about 8 days. The use of the AND is not uncommon in simulation. So I review it in a more common context for the and I discuss the related concept, the OR, at the same time. One more minute and then we'll start working this in-class problem. Let's work the in-class problem. We have expenses and their corresponding codes. Code 1 is janitorial expenses. Code 2 is secretarial. 3 is sales support. 4 is tech support. 5, 6, 7 are junior, middle, senior management. I would like to add up all the expenses in column C except for code 4. Except for code 4. How do you want to work that problem? I do not want to do it in 2 steps. I could add up all the expenses and subtract the sum if it's code 4. I could subtract the code 4 expenses. I could calculate the code 4 expenses with the sum if and separately add up all the expenses and subtract them. That would answer the question, but I'd rather do it in one worksheet function. What is that worksheet function? I review the logical tests. Equal, less than or equal to, greater than or equal to, and not equal. Two green cells for the answer. I can think of 2 ways to solve the problem. Let me say a few worksheet functions and see if one of them rings a bell in your brain. If, VLOOKUP, HLOOKUP, sum product, average, and, or, sum if, min. I said a bunch of words and 2 of them were correct ways to solve the problem. Somebody knows, come on. Sum if is one way, equals sum if. Typo. What comes next?
Expense range,
Which range?
the expense range, or no?
That comes at the end. You're on the right track, control down, control shift up. If that range of codes, let me pretend I don't know how to work this problem, that I'm uncomfortable. I'll just type a 4. That's not what I mean. I mean not equal to 4. I could type any number I want. Then you add the expenses and check the syntax. Okay, good, no error. So I'm making some progress. That is certainly not the answer that I want. The answer is quote, not equal to quote, ampersand, that very unusual syntax. $711,000 is the answer. The sum if the codes are not equal to 4, then add up the number in the corresponding expense column. What's another way, another worksheet function that could be used? Some product. Let me work it wrong and you tell me what I did wrong. I overwrote my formula. Here's what I'll do. I'll copy to the clipboard the formula that I just entered mistakenly. I'll undo. There, that's the correct one. I'll paste my formula, which is intentionally wrong. The answer is not 0. The answer is 711,000. What did I do wrong here? I don't have any quotes around the not equal to, but that's not an error. You do not use quotes around the not equal sign in the sum product. Sum if labels quote not equal to quote ampersand G73, that's the 4, expenses. That syntax, well, there's an error because 0 is not the answer, but it's not one that Excel can recognize. What did I do wrong? Come on. You need parentheses around the test. And I recommend you put minus minus, but you don't need the minus minus since the arrays are all the same size. I'm going to put minus minus anyway, as I almost always do. Sum product, open, minus minus. The parentheses are absolutely required, or you get a terrible error. It would be okay if it said, hey, you left out some parentheses. I did leave out some parentheses. I wish it would come back and say you left out some parentheses, but it doesn't do that. It gives me a 0 answer. In this particular case, the error was obvious. I know the answer is 711,000. In other examples, I can see, here is a code that is not 4, so the 4,900 counts, and this code is not 4. Obviously, the answer of 0 is incorrect, but in other cases where you have the sum product of this plus the sum product of that plus the sum product of that, and it displays 50 grand, and one of the sub terms, you have the first sum product, blah, 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 it's fine. The second sum product, blah, 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 is fine. The third sum product, blah, 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 is wrong. I forgot the parentheses. The fourth and the fifth and the sixth sum products are all correct. And it says 50 grand. It is not obvious that there is an error. Okay, contrast the two syntaxes. Labels, comma, quote, relational operator, ampersand, the cell containing the threshold, comma, numbers. The second syntax is sum product of minus, minus, labels, no quotes, no comma, star, a range of numbers. Parentheses is required. Let's see if I can display both formulas. Yeah. In a restaurant, a child swallows a quarter. It sticks in his throat. His parents are desperate. They're trying to dislodge it. They can't. The child is turning blue when a man walks up, turns the child upside down, squeezes his chest, shakes him, and the money comes right out. His parents are so grateful. Are you a medical doctor? Nope, I'm with the IRS. Back to the class pack. Inventory simulation, holding and shortage costs. A chemical lab performs medical specimen analysis using a chemical reagent. Basically, it's testing to see whether tests are cancerous or benign. The company,
Share your screen.
it says I'm screen sharing.
I think you're just screen sharing the cell.
Say it slower.
I think you're just screen sharing the Excel, so you need to stop share, and then when you new share, you need to click the desktop.
But I have only one screen. That's,
Well, I think when you initially shared, you just shared the application versus your desktop.
I've not seen that before. Obviously, you're correct.
Yeah, you can just go to new share and then new share it'll. And then you just go screen, yeah.
Zoomers, can you see?
Yes, thank you.
Finding that out. We use a chemical reagent, which is very expensive. We don't know how much of it we will need. 30% of the days, of 30% of work days, we need 10 units of the chemical. Half the days, we need 20 units of the reagent. A test and units, each test requires 1 unit of the reagent. So 30% of the time, we need to do 10 tests, therefore we need 10 units of the reagent. Half the time, we need to do 20 tests, we need 20 units. The remaining 20% of the time, we need 30 units. Every 3 days, the inventory needs to be replaced. That's not uncommon. Vitamin pills, antibiotics legally have to be thrown away after a period of time. I think it's a year. It may depend on how they're refrigerated. Whole blood that is donated to the Red Cross has a shelf life, something like 21 days. Foods, McDonald's cooks to inventory. If the hamburger is not sold within an hour or two, they throw it away. They won't even give it to the zoo for fear that someone would steal it and eat it and get sick, and the word would spread that somebody got sick from a McDonald's Big Mac. Lots of inventory items have limited shelf life. In this case, quite short, only 3 days. Time consuming to prepare. The question is, how much should we prepare? It's quite analogous to how many newspapers should the vendor order the day before. I don't know how many I'll need, how many newspapers I'll need, so I use simulation. Before the formal study, if you turned away customers, the boss yelled at you. Because that means if you did not prepare enough reagent, the boss would yell at me. But if you prepared too much reagent, the boss wouldn't mind at all. It's considered an accepted part of business. How much would any human being prepare in an environment like that? A lot. However, expenses were getting out of control. They were throwing away too much good inventory. They were preparing too much inventory, meaning they had to throw it away. And we wanted a formal study. They wanted a formal study. All right, see if you can fill in these 9 questions. Expected demand. It's not something I would ask you on the exam or even on the homework. But do you remember how to take the expected value of a random variable, given the possible values and the probabilities? Let's sketch that out so we'll get an approximate idea of how much to prepare. Anybody have any recollection? My favorite student excuse is, we don't have to know that. We learned that last month. "30% of the time, it'll be 10. 50% of the time, it'll be 20. 20% of the time, it'll be 30.
19.
Yes, it is. Let's see. $19 is a weighted sum of the possible values. 0.3 times 10 plus 0.5 times 20 plus 0.2 times 30. That's per day. Per 3-day cycle, remember the chemical has a 3-day life, you triple that and get 57. The maximum possible demand is 30 in a day or 90 in a 3-day cycle. The probability of the maximum possible demand is 0.2 in a day. And for a 3-day cycle, it's 0.2 cubed, which is 0.008, less than 1%. Multiply that by 100 and you get 0.8% of the time we would need 90 units in a 3-day cycle. So I think I should prepare somewhere between 57, maybe a little larger than 57, but maybe not as much as 90. 60 or 70 or 80 or 85 seem reasonable answers to start trying in the simulation, not testable. Let's go back to the class pack. We will use the empirical distribution. ran between 0 and 0.3. I construct the interval starting at 0, going up to 0.3. That means the demand is 10. I construct that interval so that a random number will lie in that interval 30% of the time, which is the given probability. The next interval starts where the first interval ends, 0 to 0.3. The next one is 0.3 to 0.8, which has length 5, which is the given probability. And the next interval is 0.8 to 1, which has length 0.2. Before we solve the model, here is a summary of the service level. I'll define that in 10 minutes. It generally means the percent of tests that we completed. The more we stop, the higher and higher the service level goes, the higher and higher the percentage of customers that we serve is. But this graph doesn't show the fact that the more we stock, the more and more money we pay to throw away reagent because we prepared too much. Let's assume the environment is competitive. We want to offer great service, but we don't have to offer 100% service. After all, the population of Greater Nashville is a couple of million. Do you think there are 2 million emergency doctors in each hospital around in case all 2 million of us get sick at the same time? No, there are not. They are Vanderbilt and all hospitals try to offer superb service, but you can't offer 100% service. From this graph, how much would you prepare? This is an easy question to answer because there are many correct answers. Virtually every answer except the one you're going to give is correct. That's a bad joke. How much would you prepare? The best service is 80. 90 is even better. Give me a number and motivate it. 75, that seems reasonable. The customer service is almost as big as 80. 0.993, 0.995, that looks negligibly worse. So the 75 is certainly reasonable. So is 70. I think 60 is not acceptable. 78.9% service, that sounds awful, even without knowing the context. 65 sounds awful. 75 or 80. Does simulation help, given that you make a subjective decision anyway? Of course it is. That's a condescending question. Simulation allows you to make an informed subjective decision rather than an uninformed subjective decision. I'll see if we have time to discuss the model there. All right. This is where we stop. That's the next in-class problem. So let's go to ChemLab. I can close simulation. Hope I didn't close the wrong one. This is the one I wanted to close. I'll check that when you're doing form. I explain what I'm doing here. Column A contains the days, 0, 1, 2, 100. Column B has random numbers. Column C is VLOOKUP of a random number, the empirical distribution. Simulates demands with the same frequency as the historical data contain. We're not using uniform. That would mean every outcome is equally likely. No, we have 30% probability of 10, 50% probability, and 20% probability. So we won't use uniform. We won't use normally distributed. We will use empirically distributed, which means VLOOKUP of a rand. Column D, the new prep equals 0 or the chosen quantity. 0 is used on days not 1, 2, 3, not 4. Let me read this. On days 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we prepare a new batch because the life is 3 days. On the other days, we prepare 0. Column E is the ending inventory. The ending inventory is a general recursive equation considering all possible cases. Ending inventory today is equal to ending inventory yesterday, minus what we used today, minus what we threw away today, plus the new quantity that we prepared today. Even though we do not prepare a new quantity every day, we prepare a new quantity every 3rd day. Let's take a look at Excel and see what I'm talking about. The first thing I want you to notice is I have a changing cell, a decision variable, red border 70. Look at column D, 7000. I want you to select D as in Delta 567 and double click the fill handle. So we get a pattern 70 0000, 70 0000, 70 0000. Every 3rd day, we prepare a batch with amount equal to J1. Let me change J1 to 1, 2, 3, 4, just to illustrate. Every 3rd day, we get 1, 2, 3, 4. That, of course, is ridiculous. Let's put a 75 in there. Let's put a 72 in there. Every 3rd day, we get whatever is in J1. Let's reset it at 70. Please take a look at columns A, B, C. A is merely an index, 0, 1, 2, 3, 4, 5. Random numbers, I copied the values, pasted them. Tests demanded. You'll have to confirm that from the VLOOKUP and new prep. Please convince yourself that A, B, C, and D are correct. Let's go back to the class pack. I hope it'll display. No, I don't need to do that. I've copied it to the Excel. Zoomers, do you still see my Excel sheet?
Yes.
Thank you. Read me, the sheet. Let's look at the column E formula. Ending inventory at the end of today is yesterday's ending inventory minus what we consumed today, minus what we threw away today, plus what we prepared today. On any given day, we may not prepare anything new. We may not throw anything away. The only time we throw anything away is if it's time to, if it's expired. It lasts for 3 days, so on day 1, you prepare a new batch. You don't throw away anything on day 1. You don't throw away anything on day 2. It's good for 3 days. On 2/3 of the days, you don't prepare anything, but that's okay. The new quantity is 0 if it's not prepared. The amount thrown away is 0 if we don't throw away anything. If no inventory is prepared, Why don't we prepare any new inventory? Because what we have is perfectly good. So how much do you throw away if what you have is perfectly good? Zero. If what you have is perfectly good, you don't prepare any new and you don't throw away anything. No inventory is prepared. The last term and the second to last term are not applicable. Well, they're both zero. The equation, the recursion, simplifies to ending inventory is previous day's inventory minus tests today. Well, that's true on days 2, 3, 5, 6, 8, 9. But on days 1, 4, 7, we do throw away something. How much do we throw away? All of it. How much do we prepare? 70 in this example. Ending inventory is equal to previous day's inventory is thrown away. The second term or the first term on the right of the equal sign, this one, E4, previous day's inventory is thrown away. So those two terms cancel and all you have is minus today's tests plus the new quantity prepared. The equation is general. We don't even need to know this. We just need to use this recursion. Let's look at the detailed simulation. Let me first note that minus 30 plus 70 is 40. Minus 10 plus 0 is 30. Minus 20 plus 0 is 10, which gets thrown away. My next sheet, I've annotated it. It's a little clearer. Minus 30 plus 70 is 40. Minus 10 plus 0 is 30. Minus 20 plus 0 is 10. That gets thrown away. Minus 20 plus 70 is 50. Minus 10 is 40. Minus 10 is 30. That gets thrown away. Minus 30 plus 70 is 40. Minus 10 is 30. Minus 10 is 20. That gets thrown away. Occasionally, you get some negatives. Let's take a look. Minus 20 plus 70 is 50. Minus 30 is 20. Minus 30 is minus 10. You do not throw away minus 10. You throw away 0. I want you to look at these two and these two diagonally down. If your inventory is positive at the last day of a cycle, you throw it away. If your inventory is 0 on the last day of the cycle, well, you can think of it as throwing it away. But if your inventory is negative on the last day of the cycle, you do not throw it away. You have that many shortages. We need to keep track of the tests we are not able to make because we didn't prepare enough. Minus 20 plus 70 is 50, but we had 10 shortages from the previous one, so it's minus 40. That's a complex recursion to keep up with. Fortunately, the operations track homework will be very similar to this problem, very similar. I changed it to a 4-day life expectancy and some other minor differences. Let's go on. I want to know, all right, let's go on. Day 0, 1, 2, 3, 4. Random number, tests prepared. That's VLOOKUP of RAND. I hope column C is not too strange anymore. We've seen that a few times. I admit it's complex. New prep is whatever you put in J1 every 3rd day. Ending inventory in E5 is equal to E4 minus C5 minus F5 plus D5, the new prep. I need to be aware of the fact, let's scroll down to row 106. Suppose, and now I'm using hypothetical numbers. Go away. Suppose we had 50 back orders one day, and then we had 60 more. 50 short, and now we're short another 60, 110, and then we have 90 more. We're now short 200. Notice that the 200 includes the 110, which includes the 50. So we cannot add all of the pink numbers in column O. We would be counting twice and even 3 times the same number. We have to add the dark pink numbers. 60 plus 40 is 100, plus 70 is 170. I must add only the numbers at the beginning or end of each order cycle. I must add each dark pink number. This is not the only time we would want to do something like that. We have a range of daily dates, and you want to count the inventory at the beginning of the week and at the end of the week, every Monday and every Friday. Here's how I do it. Let's look carefully at F6, well, F5, and G5. Equals if and. I'm calculating the amount thrown away. Did we order anything? If we did not order anything, why didn't we? Because what we have is perfectly good. So how much did we throw away if what we have is perfectly good? Nothing. Did we order? And did we end, if we did order, was inventory positive at the end of the cycle? On this day, did we order anything? And was yesterday's ending inventory positive? If so, if both of those are true, we ordered, and yesterday's ending inventory was positive, we threw away yesterday's ending inventory. That's why we ordered, because the yesterday's ending inventory was no good. Otherwise, 0. Amount thrown away. 0, 0, 0. Minus 30 plus 70 is 40. Minus 10 is 30. Minus 20 is 10. That gets thrown away, so we throw away 10. Minus 20 plus 70 is 50. Minus 10 is 40. Minus 10 is 30. That gets thrown away. Maybe it's in the hidden row. Okay, look right here. We do not throw away minus 10. We use it in the next column, which I haven't gotten to. The only time you throw away something is when you order and when ending inventory was positive. Otherwise, you don't throw it away. If you ordered something today, and if yesterday's ending inventory was positive, you throw away yesterday's ending inventory. Otherwise, we put a 0 in there. 0, 0, that one doesn't count. 0, 0, 10. 0, 0, 30, 0, 0, 20. This is how I incorporate this extremely important concept. I need to add up every third number. So I have a column next to it where every third number is copied, but the other numbers are all 0, so I don't add them up. Amount back ordered, very similar. Equals if and. We ordered something today and yesterday's ending inventory was negative. Then the amount back ordered is minus yesterday's ending inventory. When ending inventory was minus 10, we were short 10. And then again, minus 10, short 10. And there's some hidden rows in there. Now we can add up total tests back ordered. Total tests back ordered is the sum of all of column G, because I put 0 every time I'm not supposed to add the number. 40 back orders. There are some hidden rows, so you don't see them all. I see a 10, another 10. That's all I'll see. Row 37, 38, 91. They're there. Let me give you 3 minutes to review columns F and G. Here's a joke for the ladies. What do you call an intelligent, good-looking, sensitive man? A rumor. What do you call a middle-aged man on a motorcycle? An organ donor. All right, let me talk about something that's not testable. I'll tell you when you can have to wake up. 70 units ordered gives a 98% customer service level. Actually, that is testable. What's the total back orders? We just calculated it at 40. The service level is the sum of all of column C, everything that was demanded by the customers, all of column C, minus the back orders, the tests we did not meet on time, divided by the sum of all the demands, 98%. If I changed J1 from 70, say, to 65, you don't have to do this, the service level gets worse. If I changed it to 60, even lower inventory, the service rate gets lower yet. In order to properly do a simulation, you need to know this. It's not testable, but it's important enough for me to say in class. Doing a simulation is like observing a random output. If I flipped a coin and said, hey, look at this coin, you get heads when you flip it. That's not true. Sometimes you get heads, sometimes you get tails. In order to properly make a conclusion from a simulation, you have to do a bunch of independent replications and then get a confidence interval on the results. Does that vaguely ring a bell from statistics? We're not going to do that in this course. This course is not statistics, it's about Excel implementation. Not testable between the violet. You'd have to do a run, 60. Sometimes I get 82% service level, sometimes 72%, sometimes 92%. The next time I got 92% again. Sometimes 87, sometimes 37. Average them up, and that's the answer. Then do it again with 65 as the prep level. You would have to get a confidence interval, multiple replications. You could not simply run once and say, the answer is 82%. That's not true. I want you to know that, even though I won't be testing you on it. Okay, back to the real world. Wrong way. Class pack. How does the model approximate the real situation? I think it's very credible, but the model assumes that if we run out of chemical and a doctor's, we're a lab, our customers are not the individual people who have cancer, they're doctor's offices. We get a call from a doctor's office saying, I really need you to do this test, and we would probably not say, no, I can't do it, I don't have any chemical. The doctor would say, but Mr. Smith and Mrs. Jones are desperate to hear if they have cancer or not. We would probably make our employees stay past 5, even though they had dinner plans, and prepare a new batch, and we would actually serve the customers. But we don't want to tell our valued employees twice a week, you gotta stay to 7 p.m. People would quit if we had that type of environment. So the model approximates the real situation by, in the rare case that we do run out, the model assumes we just tell the customers, no, we can't do it. In reality, we will probably say, okay, we'll do it for you since this is such a serious issue. This might be cancer of the esophagus, cancer of the lungs, all the terrible things that can go wrong with people. Okay, that's not testable. That's not testable. That's not testable either. The Excel implementation is most certainly testable. I'll give you one more minute and then we'll work another in-class problem. Let's go on. I do want to make a closing statement. Notice we included uncertainty directly within the analysis. Previously, we concluded that average demand was 27 in every 3-day period. I think it was 27. We did not model demand as being 27 every day. We included it as being 30 or 10 or 20 or 20 or 10 or 10. We have randomness directly within the model. We did not estimate random things with their average. Okay. Bidding shell and the class pack. You're going to bid on a government construction project. Let me make a note of what time I started so I can keep synchronization with the next section. Something like paving all the roads in Davidson County or renovating the classrooms at all the schools in the Davidson County School District, or the National Guard Armory, or cutting the grass in the state parks in Tennessee. Your cost of doing the work you think is $230,000. Your cost of preparing the bid is $1,200. Because this is Nashville or state of Tennessee or Davidson County or the United States government or the Mexican government for that matter, past expenditures are part of the public record. If you want to know how much Tennessee pays to cut the grass, you can find that out. It's not hidden information. You don't know your competitors' bids, but you can have some information they have bid on in the past on similar jobs. Your competitors' bids will be modeled as being normally distributed with mean 310,000 and standard deviation 40,000. We're going to specify our tentative bid, $265,000. We think our cost of completing the work is 230. We are going to bid 265, at least initially. I will later simulate a bid of 270, 280, 250, and so forth. I will solve by trial and error. The cost of doing the work is $1,200, given, fixed. The cost of doing the bid is $1,200. The cost of doing the work is $230,000. Competitors' bids, mean 310, standard deviation 40. I have 3 named ranges, and I want to fill in this. Let's go to new car. No, not to new car. We'll do that at the end of the day, or more likely on Wednesday. Bidding shell. Let me zoom down a little bit. I want to populate this yellow range. I want to simulate my competitors' bids. Let's first of all look at the named ranges. C4 is called bid cost. Look at the name box, and it has value 1,200, bid cost. H4 is named project cost. C7 and 8 are not named. Other bids is the named range B16 through G16. The range with 6 cells, your 6 competitors' bids. What do I do to simulate my competitor bids? Here's the key. Oops, I've got a runaway mouse. You don't know your competitors' bids exactly, but you model each as having the normal distribution with mean 310,000, standard deviation 40,000. We need to simulate 6 bids by our competitors. And what's that formula? I think you said it right, but I couldn't quite hear you. What is the numerical bid by our first customer, our first competitor? The simulated bid by our first competitor. Maybe I should make class participation a part of the grade. I'm sure there would be quite a difference. Norm.in, does that ring a bell? Norm.in. Now there's the balloon. What's the probability? The random number. I want us all to use B15, comma, the mean. Let me make an intentional error, comma, the standard deviation. Something's wrong. They really are not going to bid minus 70,000. What did I do wrong? Norm.in, B15 is the probability, C8 is the mean, C7 is the standard deviation.
You switched the mean and the standard.
Yes, I did. C8, C7 should be C7, comma, C8. So the first competitor's bid is 295, 681. And that actually drags across if we would absolutely reference C7, C8. I'll select those two and put the $4 signs in all at once, drag it right. Columns are too narrow. At this zoom, they're too narrow. So only one formula so far, B16, that copies right. Did we win the bid? Equals if our bid of $265,000 is less than all of our competitors. I'm pretending I don't know how to work this. This is the way I think. I write down what I do know, and I don't write down what I don't know, but I just put a placeholder in it. Where'd I get that from? Let me start this with a blank space so Excel won't insist that it won't complain that it's not right. Equals if C11 is less than all of our competitors' bids, then we win. Yes, the value of true is yes. The value of false is no. That's what I've come up with so far. Now, how am I gonna finalize this English? All of our competitors' bids. Shall I use the or? Shall I use the and? That would be tedious if we had 100 competitors. I don't want to use an and test, yes? Yes, indeed. The min of the yellow range. I think I might have made a typo. Oh, I started with an equal sign. So of course it wouldn't parse. If C11, that's our bid of $265,000, is less than the smallest of all of them, the smallest of all of them is 238,000 compared to 3, so we lose the bid. I'm not going to quibble with whether you should use less than or equal to. It would be so unusual that two companies would bid identically to the penny or to the dollar that we can safely ignore that situation. It's considered inappropriate anyway to ask if two numbers are exactly equal when they can have round off error in them. All right, company profit equals if. This equals yes. It's 230 minus 1,200 to prepare the bid, comma, minus 1,200. Let's see what time Sprint says it is, 16:27. So we've seen 3 examples of simulation. Let's go back to the class pack. We saw the news vendor, in which each day was one period. We simulated demand on that day and we saw whether we met the sales. If we stock 500 and demand is 600, we sell 500. We use the formula, we sell the smaller of what we stock or what demand is. We then went to the chem lab, which was a little more complicated. Every 3rd day, we order. And in the operations track homework, every 4th day you order, I believe. Then we saw the bidding simulation. We have one more to go. I'll talk about that next class. Notice in each of the 3 examples, we used randomness. At least I copied and pasted special boundaries. I did not want each of you to be looking at a different number because your computer, when you type equals RAND, it comes up with a different one. I gave you the gist of it. I will see you on Monday.